Yeah, so I bought one of them DDS units on eBay, and it draws too much current to make a nice little receiver. And then I was testing the two of them out, and there's a frequency synthesizer chip down here, and these three pins are soldered together, and these two pins over here are soldered together. They're not supposed to be. When this was made, it wasn't made correctly. China on the label, shit on the table. So I went off and I kept thinking, okay, somebody has to have an oscillator that'll go from 3 megacycles to 10, and all you have to do is turn the knob or a capacitor or a resistor. So I made that one unit with a varactor diodes, and yes, they do drift like crazy, especially if you use a 500 picofarad one. It really drifts, and it keeps drifting for over an hour. A regular Franklin oscillator with a standard tuning cap is very stable. So as I'm going through all this, I'm looking through all my options, and I read that there are stabilizers that work between 1 megacycle and say 15, whatever. That's what I want. Well, in there, you have to switch a switch that changes the divide by chip. So basically, what these Huff and Puffs do is they do a very narrow frequencies. Like they'll do, in this case, there's a bunch of them out there that do the 5 megacycle band. And I'm like, 5 megacycles? Well, it's a UK band. And the Huff and Puffs sort of took off over there. And so they don't even bother to put the frequencies that comes out of the unit or the frequency that has to go into the unit. And a lot of the schematics you find have been separated from the article. So you get the schematic, you look it over and you say, this looks pretty good. And then you got to go digging and find out where it came from. And you read in there the person may, on some of them they may mention it's for the 5 megacycle band. A lot of them expect you to know that, okay? So there's places on the internet where you can find several of these circuits listed, and you're digging through them, and it's a steep learning curve. And then when you finally sort of get a handle on it, you realize it's not what you want, okay? I just wanted to make my Franklin oscillator more stable, because I noticed once I put a frequency counter on my Franklin oscillator, it was drifting all over the place. Well, it turned out to be I had switched my Franklin oscillators, the ones in the ammo can in this radio and the other ammo can, they don't drift that much. They're using a standard tuning capacitor, one with the plates. Now, probably if you took a smaller tuning cap and just had it tune a certain ham band, it would drift even less because you don't have the plates to heat up or cool and expand and contract. But I have on mine, I have a 365 picofarad cap on my Franklin oscillator, and it's pretty decent. Okay, shortwave's fine, regular thing. Sideband works good. After it warms up, it's fine. Okay, but I just started thinking, you know, it'd be really nice to build a really small oscillator. You know, get away from this nightmare. Okay, because like I showed you on one video, you have this, but then you need the rotary, then you need the keypad. Without those two, this is worthless. And I know people are buying these things and not realizing that they're going to need that. Okay, that's what I found. I bought it. I was like, wow. And then I have it in my hand. I'm like, how do I change this? And I'm like, uh-oh. And then I went looking, and I found one vendor that was brave enough to put the schematic on one of the pages and what you needed to make this thing actually work. Okay, so basically, this is almost bigger than what I want the radio to be. And now I think, well, I have radios. Basically, if I'm going to go with that type of DDS system or a phase lock loop, I already have the radio. But you know that Kenny Rogers song, you got to know when to hold them, know when to fold them, know when to walk away, know when to run. Now, I tell you, these projects are to keep me busy, but they have to have an end point where they accomplish something. Okay, now in this case, I learned my lesson. I did do a lot of reading. Initially, I did a lot of reading, but I didn't realize that they only do very specific bands. And it's very important, like in ham radio, that you stay on frequency, okay? And that's why people started building these Huff and Puffs. And that electroluminescence radio, you have to change stuff in order to change the frequency. I don't want that. I want one knob on the front of the radio, and as I tune it, the frequency counter goes up. And go the other way, the frequency goes down, and you might have in the middle of the knob, you might have a slow, okay? I had one of them on a 1937 Philco radio, and the outer knob was fast to go from one end of the band to the other, and in the middle was a fine tuning, a veneer dial. And I'll call it fine tuning because it's not a real veneer. But anyway, that's what I had, and I liked going up and down the band slowly, and you pick out every little station that's sitting in there. Now, back in the old days, I told you I didn't understand what an image frequency was. So there were many times where I was out of the band and I was on an image frequency, and it was Voice of America, because Voice of America was really strong back in the day, and they transmitted like on 15 frequencies at once. So the whole band, the whole shortwave was peppered with stations, whether they were first stations, second harmonics. There was all kinds of stuff, and the Russians were up and down the band, and then in between were the smaller countries, Quito, Ecuador, and places like that. And then Africa's Johannesburg, South Africa. Yeah, they used to play. Well, I think it was Waltzing Matilda was their interval signal, but this project turned to be total bad. I mean, and I got in contact with the guy that is alive, Hans Summers. He's in England, I guess, UK. And I asked him some questions. He answered some of them, but I didn't realize that over there they were on 5 megahertz. And at one point, he mentioned 5 megahertz, and I'm like, I thought when I saw that on some of the schematics, I thought that might be just a reference frequency to go into the circuit, but it's not. That's actually the band that they're trying to stabilize for a receiver. Okay, so I wanted continuous stabilization from 1 megacycles on 1 megahertz all the way up to say 10 for a specific radio I want to build. And I can do it with my other portables. It's no big deal, but like this here, I didn't realize I built it, and the guy built this basically just to see what he could do with the least amount of parts. And I walked right into that because in my mind, this is about how many parts I wanted to add onto my Franklin. Okay, I didn't want to go crazy, so I started building this thing down here, and I started realizing I only get response in a certain area, and I'm like, you know what? That makes sense, because you're taking a watch crystal, and you're dividing it down, and then you're feeding that in to a flip-flop, and then your reference signal comes in, and they mix together, and they produce when they're at a certain phase, they produce a pulse which charges these capacitors up, which then feeds the varactor diode, which brings it back into frequency. But it's not going to do 1 megacycle to 10 megacycles without some type of switching on the divide by the watch crystal chip that divides the frequency. So in my mind, this has been a total a rabbit hole. And I said it had a basement. Here's the basement. You build a circuit and find out, well, basically, it doesn't work that good. Did a nice job on it, took my time, all exact parts. Okay, so the rabbit hole had a basement. This is the basement. And that Kenny Rogers song. You got to know when to hold them, know when to fold them, know when to walk away, know when to run. And I'm running from this project, okay? Because this isn't going to do what I want to do. And I don't want a selector switch on the front of the radio. That's not what I was shooting for. And I did find out by testing the Franklin oscillator that used the varactor, and then the ones I used in my ammo cans. I'm like, why did my ammo can radios drift that bad? And that's because the 500 picofarad varactor diode is basically a temperature sensor. The more capacitance you have out of a diode, the more temperature sensitive it is. Okay? And I mean, You could put it in a box with a heater, but it heats itself up as it's operating, and it drifts. So the thing is, the varactor I used was for an AM radio, okay? Very wide, like on a super radio. You see complaints on super radios, the older ones and the newer ones. The older ones had a tunable capacitor with the plates, and then the newer ones had varactor diodes, and the people would say it drifted, and other people said that's from the dial cord. They always throw that one out there. That's caused by the dial cord, by the way. Well, the old one had a dial cord on it. It didn't drift. Oh, I don't know. Okay, and I did learn something out of this. There was this Huff and Puff. You can also call it a stabilizer. The schematics are very vague, and then you track back to where they came from, and it's a little bit better. Okay, so if you're into it and you're looking at my thing, I would say, unless you're trying to stabilize an old tube set for ham, you might be better off getting yourself a VFO, a tube VFO. They're pretty stable, and running it that way. If you don't know how to do that, you won't know how to do this. Okay, but I like projects to stay busy, but I also like to have an outcome, a positive outcome. I'm not getting that lately. I'm going into areas that I'm just getting beat up on. And I got beat up pretty bad on this. So that's because I didn't find that definitive article. And the definitive article is someone that explains stuff, like those books for dummies. He explains that if you do build a Huff and Puff, a simple one will only do a narrow range of frequencies. So here's a guy, he's got a VFO, and it's drifting on all his different bands, and he wants to fix that. And meanwhile, he comes in on a Huff and Puff, and all those circuits are set up to do ham frequencies. So you basically, I need it for to prevent the radio from drifting on this frequency or that. Meanwhile, it's not made for that frequency. But I did learn that. I did learn stuff, and I also learned very short on words. A lot of these guys, okay, and then even going. They mentioned an article back in like a magazine. And I go find the magazine online, and I start reading it, and it's very vague. It's like they assume you know a certain amount already, but how do you know that without reading the first article? So, and they do have Huff and Puff aficionados. These are guys that's their thing is working with these circuits. Okay, I myself, I came, I saw, I left. Okay, that's where I'm at now. I think that's it. All right, that's it.